All right, number 5, we're going to solve this quadratic equation. It's kind of off the screen. Okay. All right, so looking ahead, since 17 is prime, only factors are 1 and 17, and those factors will not add to give us 2. So we will have to do quadratic formula. So it'd be okay, so we'll plug in the value. So the opposite of b, opposite of positive 2 will be a negative 2, plus or minus the square root of b squared minus 4. A is 1, understood to be a 1 here. I won't write it, but you need to understand the coefficient is a 1. A times c, which is 17. And then all of this is over 2 times a, or 2 times 1, sorry. 2 times 1. So we'll simplify this for 68. So we'll get negative 2 plus or minus 4 minus 68. Give us a negative 64. All divided by 2. 64 is a perfect square, 8 times 8. However, since it's negative, it'll be an 8i. So we have a negative 2 plus or minus 8i over 2. And now both of these terms are divisible by 2, so we can divide both of them by 2, and that will give us negative 1 plus or minus 8 divided by 2 is 4i. Okay, so here is our solution. All right, so we're going to perform the operation. So we are writing the answer in standard form, that is the whole number part or the real part plus the imaginary part. So it's just like combining like terms. So in this problem, we're just going to be combining like terms. So there's nothing to do in the parentheses, so I will just drop it. There's nothing being distributed. So we just have a negative 7 minus 3i. And since it says plus, we don't have to change the signs in the second parentheses. So plus 8. And then minus 6i. All right, so the real parts we will combine, and the imaginary parts we will combine. So I'm just kind of boxing them. So the negative 7, positive 8 will add to give us a positive 1 or subtract. And then the imaginary parts, negative 3i, negative 6i, we add those. Should be a plus in the middle here, sorry. Add those, and we get a negative 9i. So we get 1 minus 9i, and that will be our solution. 1 minus 9